So in this video, we're going to review some factoring methods for higher order polynomials. Higher order meaning that you're going to see stuff like x cubed, x to the fourth. We're going to take them, in the x to the fourth case, we're going to take them, make them look like an x squared, and then factor them using our previous tools. So here are your methods. When you are going through the homework, you are always going to try factoring out a GCF first. GCF meaning the greatest common factor. So if all of the terms have something in common, pull that out and then look for things to factor with your other ways. So you have factoring out a GCF, using U substitution, factor by grouping. This is the same factor by grouping we did back in Math 102. The only difference now is it's a higher order, so we're just sticking it with chapter 4.4. So here's our first example, factoring out a GCF. So we look at that thing and we see 8x to the 6 minus 72x to the third. Well, I can look at them and see what they have in common, the GCF being 8 from both numbers, and then they also have an x to the third in common. So once I've factored out 8x to the third, I have x squared minus 9. The x to the third came out, so it's just 72 divided by 8 gives me the 9 equals 0. Now I can factor again. So this thing right here is a difference of squares. So I have x plus 3, x minus 3. And then I carry everything else down. Now the zero product property says if you have things being multiplied to 0, things being multiplied to 0, you can set each part equal to 0. So you're going to set 8x cubed equals 0, x plus 3 equals 0, and x minus 3 equals 0. So I get 3 from the last one, negative 3 from the middle one. And then this one I would divide by 8, divide by 8. Well, the cubed root of 0 gives me 0. The any root of 0 is 0. So you get x equals 0, x to the negative 3, and x equals 0, x equals negative 3, x equals positive 3. So those are your answers. In the back of the book, you may see it written like this. You can leave it over here with all the x's written separately, or you can write it as one big set, is what that's called. Okay, the next example, U substitution, is something that is familiar, but we have to make it look familiar. So right now, I have 4x to the fourth minus 5x squared minus 9. I cannot factor x to the fourth and x squared. I only can factor if it's in standard form of a quadratic, meaning I have squared, 1, and a constant. And I have fourth, second, and a constant. So I need to make these two exponents look like the squared. So you are going to fill in x squared with a u. Now, right now, I only see 1x squared, but I can rewrite this 4. Let me erase all this. I can rewrite this 4 to be 4x squared squared minus 5x squared minus 9. Now I can very easily see everywhere that there's an x squared, I'm going to replace it with a u. That is what U substitution says. So I'm going to fill in u's. Now this is something that is much easier to factor. So really we had the two types of factoring that are kind of the major ones in the class. So with Snowflake you do a times c on top, which will give you negative 36. B on the bottom, AX, in this case AX. Now my factors of 36 that will get me to 5 are 4 and 9. Now I need 5 to be negative, so it's negative 9 positive 4. Going to reduce. So I will get u plus 1 for u minus 9. So that's my snowflake, people. Slide and divide. You have this number and you actually multiply it down there. So you get u squared minus 5u minus 36. You have 4 and 9, negative 4, or negative 9, positive 4. Divide by the thing you just slid. So, there are your two methods. You get to the same thing. Now remember, my answer is x equals. These are just factored. So in the very next one, we're going to finish it out by factoring. So solve by factoring. Alright, so there's my factors. Both methods get you there. Set each piece equal to 0. That's your zero product property. So add 9 to both sides. Okay, so there's your first answer, 9 over 4. And then this one gives you negative 1. Now remember, the directions said to solve for x, not u, x. So the very last part is going to be back sub. So I now need to replace every u with an x squared. And then I'll finish out solving them. So if you remember, the inverse operation of squared is to square root both sides. The thing that you cannot forget about the square root is plus or minus. Okay, so plus or minus the square root of negative 1, if you remember, that is actually by definition I. So I have plus or minus I. And this one, I can break it up. So the square root of 9 is 3, the square root of 4 is 2, so then my answer is plus or minus 3 over 2. So I ended up getting 4 answers, positive negative I, positive negative 3 over 2. So the same thing as before, you could write it out as a solution set. Either one is correct. I would be fine if you stop right here. If you see any of the work on the notes, I always stop there. This is how the textbook would have it. All right, last example is factor by grouping. This is just a review from Math 102. Factor by grouping only works when you have 4 terms. So I have 4 terms, 1, 2, 3, 4. Factor by grouping says, first thing you do, group up your first 2, group up your last 2. Now, of the first 2, of the green part, x squared, or x cubed plus 3x squared, the thing that they have in common, x squared, and I'm left with x plus 3. The red part, negative 4x minus 12, well, anytime that middle sign is negative, it has to fall down, and then they also have a 4 in common, which means you're now factoring out a negative 4, so everything's sign is going to change. So especially here, I see people forget negative 12, take out negative 4, leaves you with positive 3. So factor by grouping says, all right, now that this part is being repeated, you can write down the repeat, and then write down the leftover, x squared minus 4. Now I look for, can it factor more? So sure enough, that's a difference of squares, and it is factored all nicely. I'm still solving, so my very last part is going to be set each piece equal to 0. and get x equals 2, x equals -2, and x equals -3. So those are your 3 answers, and because it is a degree of 3, x cubed, I should have 3 answers.